continue with the example with a contingency table. So the first thing we want to do is study this table real quick. So we have male, female, and a right-handed and left-handed. So these are we interview 80 right-handed people. 38 were male, 42 were female, and the same thing. We interview 50 male, 38 is right-handed, 12 is left-handed. Okay, we can read any way we want. So the total is 100 people we interviewed. Okay, that's important. Total is 100 here. Now these are subtotals, right? Okay. So find the probability of randomly select the individual to be male and right, has to be together. Male and left-handed. So male and left-handed is these 12 people. So 12 out of 100. There it is. Okay, now, or, let's get tricky now. What's the probability is we're going to select someone who's a male or left-handed. Now, or means plus, so we have plus. So probability of male plus probability of left-handed. Now, are they male left-handed? Yes, we did. We just figured it out earlier, right? That's the overlap. Okay, so if you look, when we look at the chart, if we look at the male is all these people here. And then we look at left-handed, it's all these people here. Do we see how we cross 12 twice? Because that 12 we counted in male and we counted left-handed again. We double counted it, so we have to subtract one of the 12. There it is. So it's male plus left-handed minus male and left-handed. Okay, that's what the formula says. So when you do that, so you have 50 male, 20 left-handed minus 12, that's male and left-handed at the same time, you'll get your answer. Okay. Now, sometimes we write it this way. The way you write it, this is called conditional probability. Here we go. Okay, which we're going to dive into a little bit deeper later. So the probability of a woman, given that it's a right-handed, this line means given that. Right here, given. Now, given that means we already know a person is right-handed. What are the chances that person is going to be a woman? Well, if you know it's already right-handed, then you're only looking at this first column here, first row here. You're not looking at over 100 because we already tell you someone is right-handed. Then got to be these 80 people. Then what are the chances out of those 80 people is going to be a female? That's why it's 42 out of 80. There it is. Okay, that's why given that. So when you have a given that, you have to remember you're looking at subtotal on the bottom, not a total. So here's a conditional probability, right? Okay, so right there, the idea of given that. Okay, so and then it's easy to think about it. Okay, this because we did this before. Okay, so this is like the idea of now replacing a car because given that you already did something. For example, what are the chances you will get draw a heart? Okay, draw two hearts without replacing the card and a spade. You want a heart and a spade. Okay, so well, a heart is 13 out of 52. Okay, but if you don't put the card back, what happens? You now have 13 spade. Okay, you still have 13 spade. You don't, but the total is now 51. So this is conditional probability. The condition is you already took a card and you kept it. You didn't put it back. So the total now, the second time you draw the card, it changed the total. The number of cards in the deck now is only 51. Okay, same thing here. What's the probability getting 2 clubs? The chance of getting a first club is 13 out of 52. There are 13 club cards. And what are the chances of getting another club card again? And, right, you multiply. But now, since you have the first one as a club card, you kept it. So now you only have 12 left out of what? 51 total. Okay, something different from using just cards. Suppose G-Pod manufactured 100 they manufacture 100 of their new phones, G phone. Because the G phone is new to the cell phone market, there's an estimated 15 G phone that are defective of the 100. So 15 out of 100 is defective. Now, they want to test 3 out of the 100 phones. What's the probability at least one the phone is defective? Well, remember, at least one means what? Probability of none of them is defective. Well, what are the chances of none of them defective? What are the chances the first phone is not defective? Since there are 15 phones that's defective, so the first phone, the probability of getting the first phone that's not defective is 85 out of 100. Then, what are the chances you select another phone that's not defective? 84 out of 99. Because you select the phone and you kept it, right? And last but not least, what are the chances you want to continue getting the third phone that's not defective will be 83 out of 98. So you do 1 minus that and you get the probability that you need. All right, now it's easier to just using you don't do conditional probability. You use reasoning to figure it out, or you can use Bayes' theorem, which actually detail the formula how you figure it out. Okay, so this is something that's not required really, but if you want to use a formula, okay, instead of like how we figure out the answers, feel free to do so. Okay, now we're doing counting. Okay, this is called counting principle. Now, when we try to counting means we want to figure out how many possible things. In other words, how many things in the sample space. Okay, so for example, suppose a particular restaurant, you have 8 choices of appetizers, 11 choices of main courses, and 5 choices of dessert. If you're allowed to choose exactly one from each category, how many different meals options do you have? So counting principle says you just multiply the number of choices per item, and then that's what you get. So 8 times 11 times 5. So there are 440 different combinations of meal that's including these 3 items. It's possible. Okay, same thing here. There are 21 novels and 18 volumes of poetry on the reading list. Okay, now how many different ways can students select one novel and 1 volume of poetry to read? So it'd be 21 times 8. Permutation. Now we use permutation and combination it's a part of counting, but instead of choosing one item from each category, sometimes we want to choose two out of the whole thing. Like for example, the one with the last example here. What if we say the student need to pick 2 novels out of 21 and 3 poetry out of 18? That's when we start using something either called permutation or combination. Okay. So, all right. So, different way first. Let's figure this out. How many different ways can a letter of MATH be arranged? Well, so what are the choices? So, if I want to pick one letter first, if I want to try to rearrange those 4 characters, how many different characters I can arrange, right? So I have 4 because when I first pick something, I have 4 choices. Once I pick one letter, I now only have 3 to pick from, and then 2, and then 1. That's why it's 4 times 3 times 2 times 1. Okay. Now, if you remember this in algebra, we learned that another way to do this quicker on your calculator will be doing something called factorial. This will call 4 factorial. Okay, factorial means taking that number, multiply all the way down to 1, like this. How many ways can 5 different door prizes to be distributed? It's 5, right? First person can choose one of the 5 prizes, and then next person only have 4 left to choose from, 3, 2, and 1. So you multiply all the choices. But instead of doing that, you can just do 5 factorial on your calculator, equal to 120. Okay. Now, if you have a graphing calculator where you can find the probability of a factorial key, you go to math, go to probability, and you will see factorial. Now, once again, 8 people racing, right? How many ways they can get gold, silver, and bronze? Well, gold can give to any one of the 8 person, and once we select that one person, we only have 7 people left that's choosing from silver, and there's 6 people left from bronze. So this is not a counting principle. So now let's go back to permutation. So what does permutation means? So permutation is when you choose something, order matters. So things like if I want to give 3 different prices to 10 people. So the order matters. Like for example, gold, silver, and bronze. Because it does matter, you finish first, second, or third. Now, if you have 10 people race, the top 3 people finish get a medal, period. Doesn't matter, it's the same medal. Then in that case, it doesn't matter if you finish first, second, or third. As long as you finish the top 3, you get a prize. So the first scenario where order matters is something called permutation. The second scenario when order does not matter is called the combination. So we're looking at permutation first. So here it is. How many ways can 1,000 people run to get first, second, and third? Again, we're giving different prizes, right, for given title. So it's 1,000 permute 3 times. That's how you write it and how you say it. Now, again, how do you find permutation sign? It's the same place you find factorial sign. Okay, so on your graphing calculator, just type in 1000 and look for permutation. It's under math, probability, and you see MPR. Okay, that's P right here. That's permutation right here. MPR. You see this. Okay, then you type in the 3, then that's what you get. Okay. Now, how many 5-character password can you use the letter A through Z? Now, if repetition is allowed, that means if you use letter A, you can use A again. Then each time you have 26 choices. If you cannot repeat the letters, it'll be 26 times 25, 24, 23, 22. Now, this is not factorial because you didn't multiply all the way down to 1. We're only choosing 5 times, right? Only 5 characters. Okay, just want to mention that real quick. Now, combination, the thing I was talking about, when order does not matter, right here, when order does not matter. So, for example, United States Senate, okay, they want a committee that consists of 29 members, okay, and out of those, we're gonna get, we're gonna pick 19 numbers. We want to pick 19 members out of 29, but those 19 people we pick, they're just getting a seat. They're not getting like a specific title. Okay, so in this case, we take 29, we choose 19 of them. Again, how do you find this combination? How do you find NCR? Same place you find MPR. It's under math, probability. Then you'll find NCR. Okay, so the biggest deal is how do you know when to use permutation or combination? Well, ask yourself, does the order matter? If order matters, you use permutation. If order doesn't matter, combination. Okay, now using probability with it, a 4-digit PIN number select what's the probability there's no repeating digits. Well, no repeating digit means 10 times 10 times 10 times 10. Now, what are the chances there's no repeating letters? That means 10 times 9 times 8 times 7, right? Because that means no repeating. This is repeating. You divide, you get 50% chance. Okay. Now, same thing right here. Okay, if you're looking at this, if you want, what are the chances you will draw 3 aces and 2 5s? And well, it's a 5-card draw, right? So you want to figure out what the total is. The total number of combination of cards you can draw is 52 cards choosing 5. Now, why do we do combination? When we play card games, it doesn't matter you got a 1 first or 2 first or 2 first and 1 first. It's what what you end up in your hands. That's what matters. That's why I use combination. Okay, that's how we choose this. So we want, okay, so we know 52 cards choosing 5 cards, any 5 cards. Now, what's the probability you will get 3 ace cards? Well, there are 4 ace cards total. What are the chances you choose 3 of them? And you want 2 5s, or there are 2 5s out of 4 5s, right? And that's the top is what you want, and this is a total possible different 5-card combinations. Okay, same thing with the lottery. Okay, lottery, you choose 5 numbers, so 50 choosing 5, and the first number, what are the chances, right? They're saying that what's the probability of winning dollar if the single lottery ticket is purchased? Well, you want it's 1 through 48, right? And place in the machine. 6 are drawing at random. If 6 numbers match the number their player had chosen, the player wins $1 million. Okay, so if you look at it, okay, so we want to, well, the better way we're looking at this problem is like, now the reason why we have 4 out of 3, we try to match them. Okay, so and then again, lottery, it doesn't really matter, right? Because it's not what number you choose first or second, it's what number you end up with. So again, very similar to this question, that whatever you want to do with, anytime you come with the probability, you just figure out, you can think of 2 different problems. The bottom is like, what are the total possible? Okay, how many number are there total, and how many you need to choose? And the top is the specific event. So it's like, okay, then combination, you want to choose something and something. That's why you multiply, right? So then you figure out, well, you're choosing what out of what. Okay, so this question is ill-phrased a little bit, so ignore this one. That's why I'm not going after this a little bit, because this is not, they didn't read specific saying how those numbers break down, like we have the mega numbers. So this will be a better example. Okay, what are the type of question you will see on the homework and on the test? Okay, so again, just to figure out, well, if you want 3 aces, there's 3 out of the total of 4 aces, and then 2 5s out of total of 4 5s.